Hello, everyone. In this section, we are going to draw a model with a larger number of spaces so that later we can add a more complex HVAC system to it. Along the way, we will use this as an opportunity to become familiar with the drawing tools of the OpenStudio extension in SketchUp, and learn how to prepare an energy model from the geometry drawing stage, through defining spaces, fixing adjacencies, assigning thermal zones, and finally saving the project as an OpenStudio model. First, we need to make sure that the OpenStudio extension is installed in SketchUp. If you first install SketchUp on your system and then install OpenStudio, the OpenStudio extension is usually added to SketchUp automatically during the OpenStudio installation process. After launching SketchUp, you should be able to see the OpenStudio toolbar in the software environment. However, if SketchUp was not already installed when you installed OpenStudio, the extension may not be added automatically. In that case, you need to download and install the OpenStudio extension for SketchUp separately. To do this, download the extension file in the appropriate format, usually RBZ, and add it through the extension installation path in SketchUp. After installation, close SketchUp once and reopen it so that the OpenStudio toolbar becomes active. Before we start drawing, there is an important point we need to understand. Objects that are drawn directly with the regular SketchUp tools are different from the objects that OpenStudio recognizes as energy modeling elements. In SketchUp, we can create lines, surfaces, volumes, or different groups. But these objects by themselves do not have an energy modeling meaning for OpenStudio. In other words, if we simply draw a room using the line or rectangle tools in SketchUp, OpenStudio will not necessarily recognize it as a space, an exterior wall, a roof, a floor, or a window. In contrast, when we use the OpenStudio tools, the geometry we draw contains energy model information. For example, surfaces can have a surface type, such as wall, roof, ceiling, or floor. Each surface can have a boundary condition, such as outdoors, surface, ground, or adiabatic. So, our goal is to draw the geometry in a way that OpenStudio can recognize it as a valid energy model. Now, let's create a new OpenStudio model. To begin, from the OpenStudio toolbar, we activate the option for creating or selecting a new space. In OpenStudio, a space represents a building space, such as a room, an office, a classroom, a corridor, or any area that needs to be defined in the energy model. After creating the new space, we double-click on it to enter the edit mode. Usually, the geometry of each space is placed inside a dedicated group. This allows OpenStudio to identify which surfaces belong to which space. At this stage, we draw a simple floor plan for the first space using the rectangle tool. You can also use other drawing tools to do this. First, we create the floor boundary, and then we create the walls, roof, and the other surfaces that form the space. Here, I use the push-pull tool. OpenStudio usually does a reasonably good job of detecting the walls, roof, and floor, and you can use the colors shown here to check whether the surface types have been assigned correctly or not. If we are drawing the model in 3 dimensions, we need to make sure that the space is completely enclosed. This means that the floor, roof, and walls must be properly connected, and there should be no gaps or extra surfaces in the model. Now, let's draw a window on one of the exterior walls. To draw the window, we select the wall surface and create a smaller surface on it using the surface drawing tool. This surface should be recognized as a subsurface. In OpenStudio, windows and doors are usually sub-elements of a main surface. In other words, a window must be placed on a wall, and a door must also be associated with its corresponding wall. If the surface you draw is completely inside the wall surface, it is recognized as a window by default. Next, we draw a door on one of the walls. Similar to the window, the door must also be located inside the wall surface and should not extend beyond its boundaries. If the bottom edge of the surface coincides with the bottom edge of the wall surface, it is recognized as a door by default. Of course, later we can change the type of all of these surfaces and subsurfaces if needed. If a window or door is not properly placed on the wall, OpenStudio may not recognize it as a valid subsurface, or it may cause errors during simulation. In the next step, we create a second space adjacent to the first space. To do this, we exit the current space by clicking outside it, and then define a new space. It does not matter where the space object is initially placed, but when drawing the geometry, we draw it next to the first space, so that one of the walls of the second space is exactly adjacent to the wall of the first space. This is the typical situation where 2 rooms are next to each other and share a common wall. In the same way, we create another space on top of the first space. An important point to keep in mind is that even though the spaces are visually placed next to each other, OpenStudio does not always detect the adjacency between the two surfaces automatically at the beginning. The wall between two spaces may still be recognized as an exterior wall, or outdoors, while it should actually be defined as a surface adjacent to another space. To check the status of the model, we use the OpenStudio render tools. OpenStudio provides several display modes or render modes that help us inspect the model from the perspective of energy modeling information, not just geometry. One of the important modes is rendering the model based on surface type. This is usually the default display mode. In this mode, each surface is colored based on its type. For example, walls, roofs, floors, windows, and doors each have a different color. You are already familiar with this color scheme from the internal drawing tool in OpenStudio. This display helps us check whether the surfaces have been correctly recognized as wall, floor, roof, ceiling, window, or door. Another important mode is rendering based on boundary condition. In this mode, we can see what boundary condition each surface has. For example, we can check whether a wall is an exterior wall in contact with outdoor air or an interior wall connected to a surface in an adjacent space. This is very important for checking adjacencies between spaces. Now we switch the model to the boundary condition render mode. In this display mode, the blue color means that the adjacent environment of these surfaces is considered to be outdoors. If I turn on X-ray mode, you can also see the internal surfaces. Notice that the shared wall between the two spaces is still displayed as outdoors. This means that OpenStudio has not yet detected the adjacency between these two spaces. In a correct model, the shared wall should be defined with a surface boundary condition. This means that each surface should recognize its corresponding surface in the adjacent space. In this case, the surface color should be green, but here it is still blue. To fix this issue, we use the intersection correction and surface matching tools. First, we run the tool for intersecting or correcting intersections. This tool helps split and correct surfaces that intersect with each other. This step is especially important when several spaces are located next to each other or on top of each other, and their shared surfaces must match exactly. After correcting the intersections, we run the surface matching tool. This tool finds the corresponding surfaces between adjacent spaces and changes their boundary condition from an exterior condition to an adjacent surface condition. In simple terms, using this tool, OpenStudio understands that the right wall of the first space is the same as the left wall of the second space, and that these two should be recognized as a shared surface between two indoor spaces. After running this tool, we check the model again using the boundary condition render mode. Now we should see that the shared wall is no longer displayed as an exterior surface, and its color has changed to green according to the surface boundary condition. This means that the surfaces of the two spaces have been matched, and the adjacencies have been corrected. Next, we need to check the thermal zones. In OpenStudio, each space should usually be assigned to a thermal zone. A thermal zone is an area that is treated as a single unit in terms of temperature control, ventilation system, and thermal conditions. A space may have its own independent thermal zone, or several spaces with similar conditions may be assigned to one shared thermal zone. If there are spaces in the model that do not yet have a thermal zone, we can use the tool for assigning thermal zones to spaces without thermal zones. This tool is available from the path shown here. It automatically creates thermal zones for spaces that do not have one and assigns those spaces to the corresponding zones. After running this command, we can check the information for each space and make sure that an appropriate value has been assigned in the thermal zone field. To do this time we set the render mode based on thermal zone. As you can see, each thermal zone now has its own unique color, which shows that each space has its own dedicated thermal zone. Now our model is ready in terms of initial geometry, space definitions, surfaces, windows, doors, adjacencies, and thermal zones. At this stage, we need to save the model as an OpenStudio model. To do this, we use the Save or Save As option and save the file in OSM format. The OSM format is the main file format for OpenStudio models, and it contains information related to geometry, spaces, surfaces, materials, constructions, internal loads, schedules, systems, and other energy-related data. Saving the model at this point is very important, because from here onward, we can open it in the OpenStudio application and complete the remaining energy model settings. In this way, the geometry that we have drawn in SketchUp has now been converted into a more complete OpenStudio model, with defined spaces, matched surfaces, correct boundary conditions, thermal zones, and simulation-ready building constructions. In the final section, we look at how to use constructions and materials from a previous OpenStudio model. Sometimes, we do not need to define materials and building constructions from scratch. If we already have an OpenStudio model that includes the materials and constructions we need, we can import them into the new model. To do this, we bring in the previous model as a source model or library. Then we select the required materials and constructions from that model and add them to the new model. After transferring this data, we can assign the appropriate construction to different surfaces in the new model. For example, to exterior walls, roofs, floors, windows, and doors. During this process, a number of definitions, constructions, and other objects may also be imported. Some of these may have been created by default based on the ASHRAE standard. We can delete them if we do not need them. Also, in the Geometry tab, we can see that the model we created in SketchUp has been imported correctly. Now, by setting the weather information and configuring the outputs, our model is ready for simulation. Modify the different parts of the model based on what you see in these images, so that the model is ready for the next steps.